Mars is famous for its volcanoes, canyons, and ancient river valleys, but some of its most active geology happens in slow motion, powered by wind. Over time, strong gusts can loft sand grains that ping and scrape at exposed surfaces, gradually carving landscapes the way a sandblaster etches metal. Recently, Mars Express Orbiter captured this image of a series of yardongs near the Eumenides Dorsa Mountain. The ridges all lean the same way, slanting and curving in from the lower left of the frame, which reflects the direction of the prevailing wind in this region. The view from here spans an area nearly the size of Belgium, turning what might sound like wind ripples into something far more dramatic, an organized, tens of miles-long pattern of erosion that's been working the same material over and over again. The yardongs likely formed more recently, even on top of this lava raft terrain, which hints at a long, layered history where volcanic resurfacing came first and wind erosion arrived later to rework the landscape. Images like this are a reminder that the planet is still actively changing, just not always through earthquakes and eruptions. Yardongs are evidence of sustained, directional winds strong enough and consistent enough to sandblast soft rock over large distances, and that makes them valuable for understanding modern Martian climate and near-surface conditions. This view showcases a dramatic impact crater on the red planet, with its debris wings unfurling across the surface like a butterfly in flight. The image shows a slightly elliptical crater measuring roughly 12 miles east to west and about 9 miles north to south. The crater is surrounded by twin lobes of material that fan out to the north and south, evoking the delicate symmetry of a butterfly's wings. Typically, materials are expected to be thrown outwards in all directions by a crater-causing collision. However, the space rock that sculpted this crater came in at a low, shallow angle, resulting in the interesting and atypical shape seen here. The crater lies within the Idaeus Fossae region of Mars, in the planet's northern lowlands, an area thought to harbor reservoirs of subsurface ice. The image reveals debris that appears unusually smooth and rounded, suggesting that the impact may have struck water or frozen ground. As the ice melted, it likely triggered a fast-moving mudslide, leaving behind the distinct fluidized material that now stretches outward in the crater's wing-like extensions. Several other interesting surface features are also captured in the image. Around the crater rise steep, flat-topped mesas, some more than 1,000 meters high. Their dark, exposed edges hinting at ancient lava or ash flows that once shaped this terrain. The mesas stand out clearly against the tan-colored surroundings due to the layers of dark material that have been exposed along their edges. As on Earth, this material is probably rich in magnesium and iron, and created by volcanism. This region likely saw quite a bit of volcanism in the past, with lava and ash deposits building up over time and being buried by other material through the years. This isn't the only butterfly-like crater on Mars. Another sits in Hesperia Planum, a volcanic plain in the southern highlands, but such formations remain rare. Each example helps scientists better understand not only the angle and force of the impacts that formed them, but also the hidden layers of Mars' surface and what conditions existed when the collisions occurred.